close your eyes for a moment and picture a dinosaur. What do you see? I'm willing to bet it's a Tyrannosaurus rex. Its massive head, the size of an armchair, is thrown back in a deafening roar that echoes through a misty, prehistoric jungle. Its tiny two-fingered arms are flexing, and the ground itself is shaking with every thunderous footstep. It is the icon, the king, the ultimate predator, the monster that has dominated our collective imagination for over 100 years. But this image, as powerful and ingrained as it is a profound deception. It's a trick of time. Because the T-Rex isn't the beginning of the story of the dinosaurs. It is the final, closing paragraph of the last page of an epic novel, a saga 150 million years in the making. To truly understand the Age of Dinosaurs, we have to forget the T-Rex for a moment. We have to travel back to a world before them. A world that had to be burned to the ground in a planetary scale apocalypse to clear the way for their unprecedented reign. Our story begins not with a roar, but with a whisper of death on a global scale. We are in the Permian period, 252 million years ago, long before the first dinosaur would ever walk the earth. The world is a strange and utterly alien place. Life on land is dominated not by lizards or reptiles as we know them, but by our own distant, pre-mammalian relatives, a diverse group called the synapsids. The most famous of these is the Dimetrodon, with its magnificent, sail-like structure on its back. And no, despite what your childhood toy collection told you, it was absolutely not a dinosaur. It was closer to us than to a T-Rex. The world was full of these strange proto-mammals and bizarre, armored amphibians with heads like toilet seats. Then it all ended. An event we now call the Great Dying, the Permian Triassic extinction. In a region we now know as the Siberian Traps, a series of massive, prolonged volcanic eruptions began. This wasn't a single mountain exploding, it was the Earth's crust splitting open. Lava poured over an area the size of a continent, releasing colossal amounts of carbon dioxide, methane, and other greenhouse gases into the atmosphere. The world cooked. Global temperatures skyrocketed. The oceans, absorbing this excess CO2, turned acidic, dissolving the shells of marine creatures. This warming also starved the oceans of oxygen, creating vast, stagnant, dead zones. It was a planetary murder-suicide, an almost perfect storm of extinction mechanisms. Over 95% of all species in the oceans and 70% of all terrestrial species were wiped off the face of the planet. It is the closest life on Earth has ever come to being completely and utterly extinguished. For millions of years, the world was a silent, post-apocalyptic wasteland. But in the ashes of this apocalypse, a few hardy survivors emerged, scrabbling for a foothold in a hot, dry, hostile world. The planet's continents were now fused into a single, giant supercontinent we call Pangaea. And among the survivors was a group of reptiles called the Archosaurs, the ruling reptiles. This was a family on the verge of a civil war for the soul of the planet. One branch of this family, the Pseudosuchians, would lead to the crocodiles and their relatives. The other branch, the Avemetatarsalia, would lead to the pterosaurs, the birds, and, of course, the dinosaurs. In the early Triassic period, the crocodile line was winning, and it wasn't even close. The top predators of this era were creatures like Postosuchus, a massive, bipedal crocodile relative that looked uncannily like a T-Rex but was, in fact, on the completely opposite side of the family tree. So where were the first dinosaurs? They were there, but they were not the kings. They were the underdogs, the supporting cast. Creatures like Eoraptor, the Dawn Plunder, and Herosaurus, found in what is now Argentina, were small, nimble, two-legged predators, no bigger than a large dog. They were fast and adaptable, but they were living in the shadows of their larger, more powerful crocodile cousins. So, The first dinosaurs were basically just ankle-biters running from giant land crocs? Pretty much. But they possessed a secret weapon, a subtle but revolutionary evolutionary innovation. It was in their legs. Unlike the sprawling, lizard-like stance of many other reptiles, dinosaurs evolved an erect, parasagittal stance, with their legs positioned directly beneath their bodies, just like a mammal or a bird. This allowed for more efficient, faster, and more sustained movement. It was a key advantage that would eventually allow them to outlast and outcompete their rivals. As the Triassic progressed, the dinosaurs began to diversify. The first long-necked herbivores, the prosauropods like Plateosaurus, began to appear in Europe. These weren't true sauropods yet, but they were the first sign of the gigantism that would come to define the dinosaurs, reaching lengths of up to 10 meters. The world was still a harsh place, the interior of Pangaea mostly arid desert. But then, 201 million years ago, the planet's luck turned sour again. Another mass extinction event, the Triassic-Jurassic extinction, struck. This one was likely caused by another bout of massive volcanic activity, this time as Pangaea began the long, slow process of breaking apart. This event was not as severe as the Great Dying, but it was incredibly precise in who it targeted. It wiped out most of the large amphibians and, crucially, it wiped out the dinosaurs' main competitors, those big, dominant, crocodile-line archosaurs. The stage was now empty. The competition was gone. The world was about to enter a new, lusher, wetter age as the continents drifted apart, creating more coastlines and more moderate climates. The underdogs had survived 2 global apocalypses. Now their time had come. We have now entered the Jurassic period, the Age of Giants. When you think of the Jurassic, you think of titans. And you would be right. The breakup of Pangaea created more humid environments and vast forests of conifers, ferns, and cycads spread across the land. And in these lush, all-you-can-eat buffets, the dinosaurs exploded in size. This is the era of the sauropods, the most colossal land animals to ever walk the earth. You know their names. Brachiosaurus, with its high-arched neck and giraffe-like posture, reaching up to browse on the tallest trees. Diplodocus, a creature so impossibly long, over 30 meters, longer than a basketball court, that most of its length was just a whip-like tail and an even longer neck. And their size is one of the greatest secrets of their success, a puzzle that paleontologists have been working on for decades. How did they get so big? It was a perfect storm of evolutionary innovations. Firstly, they had incredibly lightweight bones for their size. Like modern birds, their vertebrae were not solid bone. They were hollowed out and filled with a complex system of air sacs connected to their respiratory system. This is a feature called pneumaticity. It meant a brachiosaurus's neck, as long as a bus, was mostly air, making it incredibly strong but relatively light. This bird-like breathing system was also hyper-efficient, allowing them to extract more oxygen from the air. Secondly, they didn't chew. They were bulk browsers, using peg-like teeth to strip entire branches of vegetation and swallowing it all whole. The real processing happened in their massive guts, aided by stomach stones called gastroliths, which helped grind down the tough plant matter. This meant they didn't need big, heavy chewing muscles and a giant, heavy head. A small, lightweight head on a long neck is a very efficient food-gathering machine. And finally, they grew at an incredible rate. Fossil evidence from microscopic analysis of their bones shows that a baby sauropod, which might have hatched from an egg the size of a soccer ball, could gain over 10 kilograms a day, reaching near adult size in just a decade or two, a growth rate that rivals modern whales. But with giant herbivores, come giant predators. The apex predator of the late Jurassic, particularly in North America, was the mighty Allosaurus. It was a fearsome hunter, up to 12 meters long, with powerful legs, 3 clawed hands, and a mouth full of blade-like, serrated teeth. But how does a creature like an Allosaurus take down a fully grown, 80-ton sauropod? The secret is, it probably didn't, at least not alone. Like lions on the Serengeti, they were likely pack hunters that focused on the young, the old, or the sick. Fossil evidence, like the Cleveland Lloyd Dinosaur Quarry in Utah, where dozens of Allosaurus skeletons have been found together, suggests they may have been social animals. We have found Allosaurus teeth embedded in the bones of sauropods, and sauropod tail vertebrae with healed injuries from Allosaurus attacks. It was a brutal, epic predator-prey relationship played out on a colossal scale. The Jurassic wasn't just about giants, though. It was also an age of armored marvels. Meet the Stegosaurus, a creature famous for two things: the massive, kite-shaped plates on its back, and a brain the size of a walnut. Now, let's clear something up. The idea that it had a second brain in its hips is a complete myth, a misinterpretation of a large nerve canal in the pelvic region. But its real secrets are just as cool. Those iconic plates were not for armor. They were thin, shot through with blood vessels, and poorly positioned for defense. They were likely used for thermoregulation, turning to the sun to warm up or to the wind to cool down, and more probably, for display, to attract mates or intimidate rivals by flushing with color. The business end of the Stegosaurus was its tail, which was armed with 4 menacing meter-long spikes. The official name for this weapon? The thagomizer. And no, that's not a Latin term. It was coined in a 1982 Far Side comic strip by Gary Larson, where a caveman points to a diagram of the spikes and says, "And this end is called the thagomizer, after the late Thag Simmons." Paleontologists loved it so much, it became the official scientific term. While the dinosaurs were conquering the land, the skies and seas were being taken over by their reptilian cousins. It's a crucial fact that often gets confused. The flying pterosaurs and the swimming marine reptiles were not dinosaurs. They were distinct groups of reptiles that evolved alongside them. The Jurassic skies were filled with pterosaurs like the long-tailed Rhamphorhynchus and the more famous, short-tailed Pterodactylus. They were the first vertebrates to achieve powered flight, with wings made of a membrane of skin and muscle stretched along a single, incredibly elongated fourth finger. The Jurassic seas, meanwhile, were a terrifying place, a real-life monster movie. They were ruled by the marine reptiles. The ichthyosaurs, which evolved a body shape remarkably like a dolphin through convergent evolution, were built for speed. The plesiosaurs, with their long, serpentine necks, barrel-shaped bodies, and 4 powerful flippers, were the inspiration for the Loch Ness Monster. And the apex predator of the Jurassic seas was the mighty Liopleurodon, a massive pliosaur, a type of short-necked plesiosaur, with a skull over 3 meters long, filled with teeth the size of daggers. The ocean was not a safe place to go for a swim. The Jurassic was a world in balance. An established, thriving ecosystem of titans, armored tanks, and fearsome predators. But the Earth is never static. The continents continued their slow, inexorable drift apart. The world was changing again. And this change would set the stage for the final and most extreme act of the dinosaurs' reign. A new world was dawning, one that would see the evolution of the most famous, most advanced, and most terrifying dinosaurs of all time. We are now entering the Cretaceous period, the Age of Extremes. The Cretaceous world would be almost unrecognizable from the Jurassic. The continents were breaking up into shapes we would recognize today, creating more isolated landmasses and unique evolutionary pathways. And the single most important evolutionary event of this period occurred: the evolution of flowering plants, the angiosperms. For the first time, the world had color. It began to blush. This explosion of new, fast-growing, and highly nutritious food sources triggered an evolutionary arms race between the plants and the herbivores. The sauropods, though their numbers were dwindling in the northern continents, made one last, colossal stand in the south. This was the age of the titanosaurs, the largest land animals of all time. Argentinosaurus, discovered in what is now Argentina, may have reached lengths of over 35 meters and weighed up to 100 tons. It was as heavy as a Boeing 737. Its vertebrae were the size of car tires. How can we even comprehend a creature of that scale? The answer is we can't, not really. It is a scale of life that our world no longer possesses. But the real success stories of the Cretaceous herbivores were the new, highly evolved models. The hadrosaurs, or duck-billed dinosaurs, became the cows of the Cretaceous, vast herds of them roaming the landscape. Their duck bills were designed for cropping vegetation, and their mouths were filled with hundreds, sometimes thousands, of tightly packed, self-sharpening teeth arranged in dental batteries, making them the most efficient chewing machines of their time. Many, like Parasaurolophus, had large, hollow, bony crests on their heads. For years, we thought these were snorkels. A ridiculous idea. Computer modeling has shown they were actually resonating chambers, connected to their nasal passages. They were essentially dinosaur trombones, likely used to produce deep, booming, low-frequency calls to communicate with the herd over long distances. Imagine a whole herd of them calling to each other across a vast floodplain. An ancient, haunting orchestra. If the hadrosaurs were the cows, then the Ankylosaurus was the living tank. A low-slung, four-legged fortress, covered in thick, bony plates called osteoderms, with even its eyelids made of bone. It was armed with a colossal, bony club at the end of its powerful tail. This club was not for show. Biomechanical studies have shown it had enough force to shatter the leg bones of a large predator. Ankylosaurus was the ultimate defensive dinosaur. And then there were the horned dinosaurs, the ceratopsians. The most famous, of course, is the mighty Triceratops. It was a formidable beast, the size of an elephant, with a huge, bony frill protecting its neck, and 3 massive horns on its face. We used to think the frill was just a shield, but it was shot through with blood vessels and was likely brightly colored, used primarily for display and species recognition. And those horns were deadly weapons. We have found Triceratops bones with healed puncture wounds from the horns of another Triceratops, a clear sign of head-to-head combat. And we have also found a T-Rex brow horn with a healed Triceratops horn gouge in it. This was not an easy meal. So we have the ultimate defensive herbivores. The world was crying out for the ultimate predator. And in the final few million years of the Cretaceous, in western North America, it arrived. We have now reached the king, Tyrannosaurus rex. Let's get a few things straight about T-Rex. Forget what you saw in the movies. Its vision was not based on movement. It had excellent, forward-facing, binocular vision, with a visual acuity better than a hawk's. Its tiny, 2-fingered arms were not useless. They were heavily muscled and could likely curl over 400 pounds each, possibly used to hold struggling prey close. And its sense of smell was incredible, with huge olfactory bulbs in its brain, suggesting it could track prey over vast distances. But its real weapon was its mouth. The T-Rex had the most powerful bite force of any land animal that has ever lived, estimated at over 12,800 pounds per square inch. That's enough force to crush a car. It didn't just slice meat. It was a bone crusher, its thick, banana-shaped teeth designed to withstand immense pressure, pulverizing the skeletons of its prey to get at the nutritious marrow inside. Was it a scavenger? Was it a predator? The answer is almost certainly both, like almost every large carnivore alive today. It was the undisputed apex predator of its time. But the T-Rex wasn't the only fearsome carnivore. The Cretaceous was also the age of the raptors, the dromaeosaurs. And here we have to address the biggest dinosaur myth of all time. The velociraptors in Jurassic Park? They are a lie. A glorious, entertaining lie, but a lie nonetheless. The real velociraptor, from Mongolia, was about the size of a turkey. The movie raptors were based on a much larger North American relative called Deinonychus. And they didn't hunt in complex, coordinated packs like wolves. But their most important secret, the one that changes everything about how we picture them, is that they were covered in feathers. That's right, feathers. We now have indisputable fossil evidence, from creatures like Sinosauropteryx found in China, with its fuzzy coat of protofeathers preserved in the rock as a carbon film, to the bones of Velociraptor itself, which have quill knobs on their arms, the same anchor points for long flight feathers that we see in modern birds. Feathers were not an invention for flight. They evolved much earlier, likely for insulation to keep these warm-blooded animals warm and for display. Many dinosaurs, including the tyrannosaurs, we have evidence of a large, feathered ancestor called Utaranus, were fluffy. The Age of Dinosaurs was not an age of drab, scaly monsters. It was an age of giant, fluffy, feathered, and likely brightly colored beasts. This isn't speculation. This is scientific fact. And it leads to the most profound revelation of all, but we'll get to that. The world at the end of the Cretaceous, 66 million years ago, was a dinosaur paradise. A thriving, stable ecosystem that had been in place for over 150 million years. There was no reason to think it would ever end. The dinosaurs were at the absolute peak of their power and diversity. But they were all blissfully unaware that a messenger of death, a 6-mile-wide rock, was screaming through the cold of space on a direct, unalterable collision course with Earth. The day the dinosaurs died began with a new, impossibly bright star in the sky. It was an asteroid, striking the Earth in what is now the Yucatan Peninsula in Mexico with the force of 10 billion atomic bombs. The initial impact would have vaporized everything for hundreds of kilometers, creating a crater over 180 kilometers wide, the Chicxulub crater. It triggered the largest tsunami in Earth's history, a wave over a mile high that swept across the globe. It triggered global earthquakes of magnitude 11 or higher and volcanic eruptions worldwide. It ejected trillions of tons of superheated rock and glass into the atmosphere, which then rained back down across the planet as glowing spherules, heating the air to oven-like temperatures and igniting global firestorms. Any dinosaur that was not in a burrow or in the water was likely cooked alive in the first few hours. But the immediate effects, as catastrophic as they were just the beginning. The colossal amount of dust, soot from the fires, and sulfur blasted into the stratosphere encircled the globe, blocking out the sun. This was the impact winter. For years, perhaps a decade or more, the Earth was plunged into a state of cold, perpetual twilight. Photosynthesis on land and in the oceans stopped. The plants died. The herbivores that ate the plants starved. And the carnivores that ate the herbivores starved. The entire global food chain collapsed from the bottom up. It was a global, systematic extinction event. Any dinosaur that weighed over 25 kilograms was doomed. The 150 million year reign of the most successful group of animals in Earth's history was over, in a geological instant. Who survived? The small, the meek, the generalists. Small mammals, our tiny, shrew-like ancestors, who could burrow to escape the heat and could eat insects and roots to survive the winter. Crocodiles and turtles in the freshwater ecosystems, which are more resilient to collapse. And one very special group of dinosaurs. But before we get to them, the extinction of the dinosaurs cleared the way for the rise of the mammals. Our own story, the story of humanity, only begins because there came to such a tragic, violent end. So, did they all die? Was every single dinosaur wiped from the face of the Earth? For a long time we thought so. But we were wrong. That secret about the feathers, the hollow bones, the bird-like breathing system, the way they nested and cared for their young, it was all pointing to one incredible, paradigm-shifting truth. One group of small, feathered, carnivorous dinosaurs survived the apocalypse. And they are still with us today. We see them every single day. We call them birds. That is not an analogy. Birds are dinosaurs. They are a living branch of the dinosaur family tree, just as we are a living branch of the mammal family tree. The hummingbirds in your garden, the pigeons in the city square, the chicken on your dinner plate, they are all the direct descendants of the theropod dinosaurs. The T-Rex is more closely related to a chicken than it is to a Stegosaurus. This is the single greatest and most mind-blowing fact about the Age of Dinosaurs. It never truly ended. It just learned to fly. The story of the dinosaurs is the story of our planet's resilience, its violence, and its incredible capacity for change. The fossils beneath our feet are not just bones. They are time machines. They are the pages of an epic novel that we are still learning how to read. And new discoveries are being made all the time, constantly changing our understanding of this lost world. The Age of Dinosaurs is a story of titans and monsters, of survival and extinction. But most of all, it is a story that reminds us that life is tenacious, that the world is ancient, and that even after the deepest darkness, life finds a way to take flight. And if you believe that this is the greatest story ever told, if you want to continue this journey of discovery with us, peeling back the layers of time to understand our world, then do us a favor. Hit that subscribe button and turn on notifications. Every click helps us continue this incredible mission of exploration. And if this story blew your mind, share it with someone who you think needs to see that the monsters of our childhood were real, and their legacy is still all around us. Thank you for traveling back in time with us. Keep digging.